Good morning, dear student. In today's lecture, we will discuss very important practical of our syllabus, that is the use of ion exchange chromatography. So, in this, we discuss the separation of a mixture of zinc second and magnesium second using anion exchanger, anion exchanger resin, and after that the estimation of separated ions. So the main purpose of this experiment is to separate the zinc second and magnesium second separately from the mixture, and there is estimation of the separated ions. Okay, so we are very much familiar with this ion exchange chromatography. Ion exchange chromatography involves a reversible reaction in which ions from the solid are exchanged with other ions present in solution. So ions with solid exchanger are exchanged with ions present in solution. If you consider some properties of ion exchanger, they are almost insoluble in water. So you can write here the properties of some exchanger. They are insoluble in water and organic solvent and organic solvent. They are insoluble in water and organic solvent. They are polymeric in nature. Polymeric in nature with high molecular weight. High molecular weight. Okay, and they have the capacity to exchange the ions reversibly with the other ions in the surrounding solution. So if you consider the theory behind this experiment, that is separation of a mixture of zinc second and magnesium second. Zinc second and magnesium second mixture can be separated from each other by ion exchange chromatography. For that purpose, the mixture of zinc and magnesium is passed through a column containing anion exchanger resin. So in this case, so if you consider, we can write here, for the separation you have to use anion exchanger resin for the separation of zinc second and magnesium second. Magnesium is eluted with dilute HCl solution. Second, Mg is eluted with dilute hydrochloric acid solution, and zinc is eluted with dilute nitric acid solution. Dilute nitric acid solution. So they are used as a elutant. So magnesium is eluted with dilute HCl and zinc is eluted with dilute nitric acid. After separation, they are estimated by complexometric titration using EDTA solution, that is ethylene diamine triacetic acid. So if you consider what you required for this experiment, so if you consider, we required zinc second solution, then we required magnesium second solution, Mg second solution, magnesium second solution. Then we required 2 molar hydrochloric acid, 2 molar HNO3 nitric acid, 2 molar HNO3. Then we required erichrome black tea indicator. Then we required buffer solution for titration, buffer solution. And then we required the EDTA solution, that is for titration 0.01 molar. So these are the some chemicals we required. Let us discuss the procedure. So if you consider the procedure, First is the preparation of column. Preparation of column. So, for preparation of column, you have to take 10 gram. First point, you have to take 10 gram umber light, umber light IRA 400, umber light IRA 400 resin. So this is your anion exchanger resin. So to take 10 gram Amberlight IRA 400 resin in 400 ml beaker. In 400 ml beaker. So you have to take the resin, 10 gram resin in 400 ml beaker. Then wash it with distilled water and allow it to soak for swelling. Okay, wash with water, distilled water. Wash with distilled water and allow to soak for swelling, to increase the particle size, swelling overnight. Overnight. So you have to take 10 gram this anion exchanger resin, wash with distilled water and allow to soak for swelling overnight. After that, in next day, you have to pour the resin in 50 ml. Third point, pour means add, pour the resin in 50 ml burette, 50 ml burette, and the condition is that there should be no air gap should be there. Okay, then wash with 2 molar NaOH. After filling into the burette, wash with alkali 2 molar NaOH and then and 2 molar hydrochloric acid. Then wash the column repeatedly with distilled water. Again, wash with distilled water. Wash with distilled water. Wash with distilled water till free from acid. It is still free from acid. Till free from acid. And the column, after that, the column is now ready for loading the mixture for separation. Column is ready for separation. Column is ready for separation. So the simple procedure is that you have to take 10 gram anion exchanger resin for separation of this cation, zinc and magnesium second, and wash with water and allow to soak for swelling overnight. Then you have to pour in 50 ml burette, and then wash with alkali and then with acid, and then again wash with distilled water till free from acid, and then it is ready for the separation. So let us discuss the second point, that is separation of zinc second and magnesium second. Zinc second and magnesium second separation. So let us discuss separation of zinc second and magnesium second. First point is that the preparation of column. Second point is that separation of zinc second and magnesium second. So first point is what? Pour the given solution. Pour the given solution means the mixture of this cation. Pour the given solution about 2 ml containing zinc and magnesium top to the column. Top to the column and wait for 10 to 15 minutes. So you have to pour the mixture of these cations, zinc second and magnesium second, top to the column and wait for 10 to 15 minutes. Evaluate the column. So first how to evaluate the column with 25 ml, with 25 ml 2 molar hydrochloric acid solution. Then you have to add hydrochloric acid solution after that. So evaluate the column with 25 ml 2 molar hydrochloric acid solution and collect the eluent as a single fraction at the rate of 3 ml per minute. So you have to collect the eluent as a single fraction at the rate of 3 ml per minute. So for 1 minute you have to collect 3 ml fraction. So evaluate the column with 25 ml 2 molar hydrochloric acid and collect the eluent in single fraction at the rate of 3 ml per minute. Then evaluate the column with distilled water. Then evaluate the column with 25 ml distilled water. Evaluate the column with 25 ml distilled water. Collect in same conical flask. That is, collect in same conical flask. So already you have to collect the fraction, that is 3 ml per minute. So after elution with what evaluate, that is you have to use water, then you have to collect all the solution, all the fraction in the same conical flask. Collect in same conical flask. Collect in same conical flask. So we already discussed, that is the magnesium, the fraction is what? The magnesium, because magnesium is eluted with hydrochloric acid. So whatever the ions which is separated, it is your magnesium, mg second. So whatever the fraction which is collected, that is your magnesium. Now the next procedure is that after separation of this magnesium, you have to evaluate the column. Again, evaluate the column with 0.2 molar HNO3 solution, 0.2 molar HNO3 solution, and then with 25 ml 2 molar HNO3 solution, and then with 2 molar 25 ml HNO3 solution. Mix both the fraction in same conical flask, or collect the fraction in same conical flask. Mix the two nitric acid fraction together. Okay, so now evaluate the column. So first, if you see the separation, pour the mixture, that is zinc second and magnesium second, top to the column, wait for 10 to 15 minutes. Then you have to evaluate the column with 2 molar hydrochloric acid solution and collect the fraction 3 ml per minute. Then you have to evaluate with water. Again you have to collect in the same conical flask, and whatever the fraction is that of magnesium. Now evaluate again after separation of magnesium, evaluate the column with 25 ml 0.2 molar HNO3 and with 25 ml 2 molar HNO3 solution. Collect this fraction together, and the second fraction, whatever we get, the second fraction is of zinc second. The second fraction is of zinc second. Again, you have to add dropwise 25 ml 2 normal NaOH to each fraction with constant stirring and dilute to 100 ml with distilled water. So the last step is what? You have to add dropwise 25 ml 2 normal NaOH solution to each fraction, that is fraction of both magnesium and zinc. So to add dropwise 25 ml to normal NaOH to each fraction with constant stirring, with constant stirring, with constant stirring, with constant stirring, and dilute it to 100 ml, and dilute up to 100 ml, dilute to 100 ml. To dilute 100 ml with distilled water in volumetric flask, and after that you can determine the amount of both zinc and magnesium by titration with EDT. So we are very much familiar with this EDT titration. So we are very much familiar with this procedure. That is, you have to take the solution, then you have to add buffer solution, you have to add erichrome black tea indicator and titrate with uh, ethylene diamond tetraacetic acid until the wine red color changes to blue. So we are not very much interested in the determination procedure. We are very much interested only in separation. So how the column is prepared, how the mixture is added, how the separation of these ions takes place, and after that separation, the determination is very easy because we are very much familiar with this determination with the LDTA solution. So this is all about the ion exchange chromatography for separation of mixture such as zinc second and magnesium second. In next lecture, we will discuss the remaining practical of this course. Thank you.